Hello and welcome to Crazy Math Productions. We're continuing our unit on systems of linear equations or inequalities. Today we're going to look into solving systems of inequalities. And just a couple quick reminders. Remember, if we have an inequality, you could have a solid line for your line. You could have a dotted line. And of course, you could shade above or below the line, or if it's a vertical line to the left or the right. And so there's a few things that you need to keep in mind when you are graphing these inequalities. The first thing is, if you followed Crazy Math Productions, you've seen that the young man is unwise and opens his mouth and just says all kinds of random stuff. The wise man, you see the little wrinkles for the wise man, he knows when to keep his mouth shut. And so you sort of add a new wrinkle with that when we were graphing the inequalities in the coordinate or Cartesian plane. What we learned was that the young man, of course, would have sort of the young man beard, and the old man would have the full beard. And so that sort of indicates that the the young man there, if you don't have the or equal to, it's going to be a dotted line. If you have the or equal to, it'll be a solid line. So keep that in mind. One last thing, something that my good friend John Altman shared with me. Eat the Y to the sky. Eat the X. Hit the decks. And so when you are looking at these, of course, you have the young man dotted, old man solid, and if the little alligator, for lack of a better term for it, the inequality symbol, is eating the Y once you have it in slope-intercept form, then you shade to the sky if it's eating the X when you have it in slope-intercept form. Very important. For this to work, it has to be in slope-intercept form. Okay, so again, we've been talking about solutions. Solution basically satisfies all inequality. What does it mean by satisfies? Well, it makes it true. If you plug in the x and the y, like we're going to do in a second here, it's going to make everything in the system, whether it be an equation, inequality, it could be 2, it could be 3, it could be 15. It has to be true in all of the equations or inequalities in the given system. So in this system, for example, in number 1, we have 2 systems of inequalities, so it would have to work for 2 of these. So let's go ahead and let's see what this is going to look like. Number 1, let's try. This is x and y. We're going to plug these in. X is 2, so we'll plug in. I'll tell you what, we'll color coordinate this. If you have a blue or a red pen, that would certainly make it a little easier. What happens sometimes that with 2 equations going on, sometimes we can confuse the 2 once we get into the work. So I like to separate them by color so it's a little easier to keep track of. So 2, I'm going to plug in for x, I'm going to plug in 2 plus the y, which is negative 3, is less than 3. If you're wondering why would you put these in parentheses, well, the reason that you put them in parentheses is that you want, sometimes if you have an exponent and a negative number, it will make a big difference whether this is in parentheses or not. So it's important just to be out of habit. Of course, in this case, it doesn't matter, but it's out of habit, just good to go ahead and put those parentheses there. 2 plus negative 3 is going to be negative 1, is less than 3. Well, this is true. How do I know it's true? Well, if I graphed a quick sketch of a number line, negative 1 would be to the left of 3. And really sort of stupid way you can remember this. If you actually literally take your hand, look at the curvature of your hand, your left hand matches this beautifully, and it's going to go to the left. So is negative 1 to the left of 3? Well, yes, it is. So this is true. Now, it doesn't have to be just true for one. It has to be true for both. So what we're going to do is we're going to go ahead and plug into the blue one as well. Now, if we'd found that the red one, it was not a solution of the red one, we could go ahead and stop. It has to be a solution to the entire system and not just one. All right, let's go ahead and plug these in. We're going to look at the blue inequality this time. So 2 times, plug in 2 for x, minus 4 onto negative 3 is greater than or equal to 8. 4 negative times negative is positive, so 4 plus 12 is greater than or equal to 8. That means that 16 is greater than or equal to 8. Now again, if you graphed a quick sketch, 8 would be to the left of 16. Now, if you're using the hand thing again, the right hand matches the curvature here. Is 16 to the right of 8? Well, yes, 16 is to the right of 8, or on top of, or equal to. So this is true as well. So since both of these are true, we're going to say determine if the ordered pair is a solution. Yes, it is a solution. So that works. Okay, let's look at number 2. Of course, we have x and y, and just always helps to label that to be very clear. We have the red and the blue. Wouldn't be a bad idea for you to pause the video and see if you can do this on your own. Okay, let's see how you did. Let's plug in x, 1 for x, plus 5 times y is 0. It's greater than or equal to 8. So the opposite of 1, that's negative 1, plus 5 times 0 is 0. And it's negative 1 is greater than or equal to 8. Now, is negative 1 greater than or equal to 8? Well, let's, again, draw a quick sketch. Negative 1 would be on the left of 8. And if you're looking at the hands, let's see, the right hand, if you put your right hand after that, that matches the curvature there. And it's saying to the right. So negative 1 is to the right of 8 on the number line, or on top of it? No, that's definitely not true. So I don't even have to continue. Since one of these is not true, just put a little slash there, negative 1 is not greater than or equal to 8, then no, this is not true. So no, it is not a solution. So if it is a solution to the first one, you have to continue through as many as they've given you in that particular system. If it's not a solution to even the first one, you don't have to go any further. It must be a solution to the entire system, or it's not a solution at all. Okay. Basically, process of solving by graphing, you've got to think, it's not going to make much sense. There's going to be so many different solutions. The only way for this to really make sense, even a table, listing them as a, 1, 2, 3, negative 6, listing them this way, that's just, it's not going to make much sense to us trying to figure out any pattern. So listing them this way, that just doesn't make much sense. Even doing a table of values listing the different solutions to the system, that's not going to make much sense either. The only way that we can organize this that's going to make any logical sense is for us to graph it, because again, there are just so many of these. So let's graph these. Let's not use any of these other methods. Let's graph it, and let's just kind of see if we can organize the in most cases, uncountable infinite number of solutions that we can find here. All right, number 3, y is less than x minus 3. Y is less than negative 2x plus 5. All righty. Okay, so solve each system of linear inequalities. Well, what we're going to do, we're going to go ahead and put this in slope-intercept form. Thankfully, it already is. Y is less than, now I'm going to put a 1 in front of the x and put that over 1. And that's going to be the slope. This will be the y-intercept. And so now what we're going to do is just to simply graph this. I'm not going to put the line yet. I'm just going to put the basic skeleton of the structure here. So let's go down 3. Plot the point. We're going to rise 1, run 1, and continue doing this a few times. Now, because this is the young man, keeps his mouth open, has the young man beard, it's going to be a dotted line. So we're going to put a dotted line through there. See if I can do a good dotted line here. It's not fantastic, but that'll work. And now, you see a little alligator here, the inequality symbol, is eating the X, so we're going to hit the X. That is, we're going to shade below. So shade below, and so we're going to shade below this. Okay? Now those are all the solutions to the red inequality. Now let's look at all the solutions to the blue inequality. Again, we're going to make this, we're going to rationalize this. We're going to put -2 over 1 into fraction format. We're going to go up 5, the y-intercept. So we're going to go up 5, 1, 2, 3, 4, 5. We're going to rise -2, run +1, and we're going to continue that. And don't make the mistake that some students do. Some students are so used to the equations that they think, oh, well, the solution is right here. Maybe what, about 2 1/2, -1/2, somewhere in that region. Don't get tricked into thinking that. No, there's going to be an infinite number of these, and we're trying to figure out exactly where those are. It's where the shaded regions overlap is really where a solution set is. So let's look here. We have the young man. Again, the old man is the or equal to. The or equal to gives you, if you're graphing it on a one-dimensional numbered line, you're going to have a solid line, solid dot, excuse me, or you could think of it as in a Cartesian plane with 2 variables, it's going to be a solid line. Now, we don't have that here. This is still the young man. This is the dotted line. So it's going to be a solid, excuse me, dotted line for the blue. And inequality symbol, the alligator has eaten the X, so hit the X, go below it. You can see this is the region here where it overlaps. Now I'm going to take a highlighter. This isn't necessary, but it's helpful to sort of visualize. So this area down here, that is really the solution set. Now, as I told you earlier, if we tried to list that as a table or list it in set notation, that's not going to make much sense. But because I have this graphic representation, I can see sort of this infinite triangle, if you will, going down in the Cartesian plane, sort of in the third quadrant, excuse me, fourth quadrant extending into the third. That is my solution set. And you can see, what does this dotted mean? Well, it's not a solution on the line. So it's not including these lines, or these rays, really, but it is inclusive between there in sort of this little infinite triangle. Okay, so we've got our solution. So you pretty much see, you put it in slope-intercept form, graph, dotted or solid line, shade above or below the line, and then find your solution set. And that's pretty much it. All right, let's try this again. Only difference in this one is that we're going to have to actually solve the red one for slope-intercept form. If you'd like to, you can go ahead and pause the video and try it. Let's see how you did. On the red inequality, let's subtract x from both sides. Divide by -2. Whoa! What happens? Remember, if you followed Crazy Math Productions, every time you divide by a negative in an inequality, you must switch the symbol. So negative divided by negative is a positive. I'm going to put a 1 here so that we get 1/2 x plus +6 divided by -2 is a -3. And so I'm pretty much ready to roll. -3 y-intercept, start with that. We're going to rise 1, run 2. And to try to get an accurate line, I'm going to go as many as will allow on my graph. Okay, again, this is young man, so it's a dotted line, which means that the points right on this line are not solutions to the inequality. And it's eating the x, so hit the x, shade below. All right, let's try the blue. Again, start with a y-intercept, positive 2. The negative, where should we put the negative? Well, it's really your choice. I'm going to put the negative in the top for the moment because it's convenient. You can put the negative in the top, the bottom, or out front. But when you're graphing, it's just easier to have the negative either on the top or the bottom, on the numerator or the denominator. Okay, so we're going to rise negative 1. That means go down 1, and run positive 2. And continue that. Now do the opposite. Put the negative in the bottom. We're going to rise positive 1, run negative 2. And there you go. Again, young man, it's a dotted line. It's eating the x, hit the dex. And you can see that the joint shaded area is right there, not including the lines because they're dotted. Alrighty, let's try a few more. Now, you're welcome to try this on your own. Just be careful of the one variable inequality. Let's see how you did. This is already in slope-intercept form, so we don't have to do any solving. Y-intercept is at negative 2. We're going to put a 1 and rationalize it. Rise 1, run 1. Alrighty, and this is old man. It's got the or equal to, so it's going to be a solid line. And I didn't quite do that well, but that's all right. All right, and now the blue. Now the blue, if you follow Crazy Math Productions, we like to call this swap the flies. We're going to pretend just a second this is y equals 3. Now it's not. Don't hear me wrong. It is not y equals 3, but we're going to pretend just a second for the sake of graphing it. For a y equals, it's the opposite of what the y-axis is. This is the y-axis, so this would be a y equals. So we're going to go on the y-axis to 3. 1, 2, 3. Put a point there. And it's going to be a y equals type line. Remember, y-axis vertical, y equals horizontal. They're always the opposite when you think about the y equals or x equals, those one variable graphed equations, or in this case, inequality. So y equals 3, it's going to be a horizontal line because the y-axis is vertical, so it's the opposite. Y-axis vertical, y equals horizontal. Now, because this is the, it doesn't have the or equal to, it's the young man, it's going to be a dotted line, so don't forget that. And now we can sort of ignore all that. Okay, now I have not shaded. I should have already done that. On the red, it's eating the X, so hit the X, shade below. And the blue, we're going to shade. Now, I don't think it's going to be very reliable to say eat the Y, hit the X, all that sort of thing. So what we're going to do instead is we're going to pick a point, say the origin. And I'm going to look at that point and see if this works. So that point, 0, 0, we're looking at the blue. We're going to plug it in and see if this point works. So plug in, this is X, this is Y, remember. So we're going to plug in 0 for the Y. 0, working with the blue, 0 is greater than 3. Now, is 0 greater than 3? No, definitely not. So this point should not be shaded. It's not a solution. So since it's not shaded, it must be shaded the other way. So we're going to shade above the line this time. And where exactly is the solution set? Well, the solution set's going to be right in here, this triangle sort of extending this way. So there's my solution set. Now you can see, if you'll follow the cursor here, it is inclusive this way. That means that the points on the line itself, those are solutions, and they're not inclusive here. So these points that are on this line are not solutions. Just above it are, but not directly on. All right, let's try number 6. And you should be fully equipped to do this, so try it on your own, and then we'll see how you did afterwards. Okay, let's see how you did. For the red, I'm going to put 1 and make that a fraction, 1 over 1. The blue, we're going to put it as 1 in front over 1, just to have something we can work with. So with the red, I'm going to start with -2, so go down to 1, 2. Put my point, we're going to rise 1, run 1. Do you have to go all the way through? No, but it just makes it a little more accurate. Okay, so this is the old man. You can see the or equal to little wrinkle on his face here. So this is the old man. Old man has a solid beard, so we're going to do a solid line. If I can graph it. Okay, and eat the Y, so to the sky. So we're going to shade above the line. All right, and the blue, we're going to go up 1, put our y-intercept. We're going to rise 1, run 1. Okay, this is a dotted line, even though it looks like that was just something I had written in. That's then not or equal to, that's just less than. So that's the young man, that's a dotted. And eat the X, so hit the dex. So we're going to shade below. And you can see that there's this narrow strip here that is shaded both ways by the red and the blue. And so that is my solution set. Inclusive here, meaning the points on the line do work, or they are solutions, and not inclusive here, which means that the points on this line, they will not fill in and work. They will not be solutions. And that brings up an interesting point. If they had been the other way, if this had been less than or equal to, and this had been greater than for the blue, then you would have a situation where there's actually no solution. And that is possible for a system of linear inequalities. If there are never shaded more than once, then you would have no solution. And that is definitely possible. So keep an eye out for that. Okay, number 7. You'll notice that for the red, it's ready to go. Blue's going to need a little bit of work, but you should be able to handle it. Go ahead and try it. Pause video, see how you do. Okay, let's see how you did. For the red, we're ready to roll. Y-intercept, +3. Negative, I'll tell you what, let's put the negative in the top. Rise -1, so go down 1 and run +2. This is the old man, so it's going to be a solid line. And eat the Y, so to the sky. Okay, for the blue, we're going to solve for Y. And the opposite of x, again, cannot combine that. Don't try that. They have to be like terms, meaning same variable combination. And now we're going to divide through by 4. Now, negative 2/4 we could reduce to negative 1/2. And I'm going to have that negative in the numerator, the top. Subtract 4 divided by 4 is 1. So here we have slope-intercept form. We're ready to roll on this one as well. So the y-intercept is negative 1. Let's go down 1. We're going to rise negative 1, meaning go down 1 and run 2. And do that a couple times. And eat the x, so hit the dex, also a dotted line. And eat the x, hit the dex. You notice, this is what I was talking about last time. There is no solution here. It is not shaded by both the red and the blue anywhere. These two have the same slope, different y-intercepts, so they are parallel, and they're being shaded completely different directions. So there is no solution set. I don't have to, but it's going to be nice for the reader to see. There is no solution. Now we are working in the real numbers for Algebra 1, so you may want to include no real solution, or in this case, you could just say no solution. All right, number 8. You notice most of the time we've been dealing with 2 linear inequalities. Now we're dealing with 3 linear inequalities. Well, the difference is just very simple. Since in the past we had a red and a blue, we were just simply looking where it was shaded by both the red and the blue. Now we're going to add a third color. We're going to have red, blue, and green. And all we're going to be looking for is where it has all 3 colors at the same time. And so if you add another linear inequality here, all you're going to be looking for is where it's shaded 3 different times instead of just 2. Okay, so y is greater than 2x. And you could add plus 0 here just to help you sort of conceptualize what's happening. So y-intercept is at 0. We're going to rise 2, and we're going to make this fraction 2 over 1. Numerator 2, denominator 1. We're going to rise 2, run 1. I'm going to go as far as I can just to make sure it's accurate. And this is the young man, so dotted line. And eat the y, so to this guy. All right, now let's do the blue. Y-intercept of positive 2. Let's see, there's a 1 here hidden, and we can make that a fraction, so 1 over 1. Rise 1, run 1. And again, we're going to go as far as we can just to make sure it's as accurate as we can make it. Now that is going to be a solid line. And here it's eating the x, so we hit the dex. It's going to be shaded below. You see, so far it's going to be this little wedge here, but we do need the green, so we're going to add the green color in here. Now remember, let's imagine just for a moment, it is not, but let's imagine that this is an x equals negative 1. Well, the x-axis is the horizontal axis here, so the x equals is going to be the opposite. It's going to be a vertical line. Now, we're going to go on the x-axis to negative 1, so to negative 1, green. And x-axis is horizontal, and x equals will be vertical. So we're going to make a vertical line here. Now, it's not x equals, it's x is greater than. So it's the young man, it's going to be a dotted line. And now we've got a little bit of a predicament. We've got to figure out which way to shade. When it's just one variable, the eat the y, eat the x, is not reliable, so we're going to have to choose something different. I'm going to look at a point that's off of the line, which is 0, 0. This is very easy to work with. And let's see if the point 0, 0 is that a solution or is it not? If it's a solution, we're going to shade to the right. If it's not a solution, we'll shade to the left. So x is greater than -1. Let's plug in 0 for x. So 0 is greater than -1. Is that true? Well, yes, it is. 0 is greater than -1. So we're going to shade to the origin, towards origin. We're going to shade to the right. And if you can see it, get my thickness down a little bit here. All right, blue is here. Oops. There we go. Blue is here. And then the green. And if my pen will work, that would be very helpful. Okay, let's find the red. Here's the red. And then the blue. And the green. So you can kind of see, I'm going to outline this in another color if I can. Let's see if I can find another color. Oh, how about purple? That should show up nicely. So you can see it's this area right here, this triangle. Okay, and there's my solution set there. It's a little confusing, but you can see this triangle defined along the red, blue, and green, inclusive along the blue, not inclusive along the red and the green because of the dotted line. Well, that'll do it for today. Thank you so much for listening to Crazy Math Productions.